Hello everyone, welcome to this tutorial. I am Jonas from Byzantine University, Hydraulic and Water Resource Engineering Department. In this tutorial, I will introduce you how to model your bridge using Hec-Ras software. This software, this Hec-Ras software, river analyze systems analyzes steady flow and steady flow. So you can do different analysis using these Hec-Ras softwares. So what do we mean steady flow? When we say steady flow, a flow in which velocity of fluid at a particular fixed point does not change with time, we call it steady flow. When we call unsteady flow, when the velocity is vary with the time, it is a transient phenomenon. So in this, to use this model, you have to know courses like open channel hydraulics, hydrology, because the discharge is the hydrology part. The other parameters about critical, subcritical flow is about the open channel hydraulics. So you have to have all this knowledge. Next to this, you have to use the Hec-Ras manual to do your analysis effectively. So before you using this bridge analyze using river analyze system Hec-Ras, you have to collect your input data. So when you say this, you have to collect the cross-sectional data. You have to know the river name, ridge name, cross-sections, stations, and elevations. So there is survey data. When we say about the station and the elevation, it is about the survey data. The other one is about the flow, is hydrology data. So all this data should be gathered before you use this Hec-Ras software. The other thing, while you are modeling your bridge, you have to check your bridge structure is called structurally sound. When we say this, it should have piers, abutment structures. When it has this, we call it structurally sound. So you have to follow the hydraulic criteria to design your bridge. What recommendations are there? You have to review all this. So this tutorial simply you know that how to insert your geometric data and analyze your steady flow. Then using your geometric data and the steady flow, in addition to this, using your bridge data by inserting your bridge data, that means roadway data, pier data, sloping abutment data, you can model your river you can model you are model you can model your bridge effectively. So you see this tutorial how to analyze the steady flow and to design your bridge using Hec-Ras software. Okay, so you can input your geometric data in two ways: by selecting this one and you can select these cross sections and insert manually on this table. You can insert manually on this table, or by arranging your river name, river ridge name, and the cross sections, stations, and the elevations on the Microsoft Excel spreadsheet, and they save the spreadsheet as command delimited way, that means CSV. Then you can import your spreadsheet Excel format file into your Hec-Ras, and then you can simply do your analysis. So I will show this the second one. Second one. So first of all, I go to File and select New Project, and I select this one. I will save my project result and local disk D. Then later I select HWRE folder. Okay, I will save in this. Then I create folder. Later I call it okay, Hec-Ras or bridge modeling, bridge modeling. You can save in this one, bridge modeling, or I can save this one, Hec-Ras one. Can save this one. Say okay. Hec-Ras one. Then I will save this bridge modeling using Hec-Ras. Then save okay. Start new project with bridge modeling using Hec-Ras. This is my file name. This one is bridge modeling using Hec-Ras. This is the title. And I saved in local disk D Hec-Ras one directory. Then I can change this unit, US customary unit, but I can change this unit to SI unit. So say okay. Go to options and then change this unit system. I select SI unit, that is System International or Metric System. Then okay. Do you want to set project units to SI? Yes. Already your project name is bridge modeling. So on the step 2, I will select this symbol, this geometric data editor, then you can view or edit your geometric data by using this. So I click this one. There are many symbols found in the vertical and the horizontal. So you see there is ridge, river, ridge. There is junctions, cross sections, grid and curved, inline structures, lateral structures. There are very simple representing on this one. So I can select my cross sections. So I go to file, and I can save the geometric data. I can write here geometric data one. Geometric data, then okay. Already your geometric data is saved in your folder Hec-Ras one. So select this simple cross sections. You can insert your cross sections data manually on this chart or by copying the file, the data from your Microsoft Excel and paste here. You can fill this one, or you can import your Microsoft Excel data to this software. So I will show this one. Go to file and import geometric data, select file, then import geometric data, deselect this one. Since I am saving my Microsoft Excel data in this format, I will select this one. So this data, this geometric data is saved in this folder. I select this one. Okay, like yes. Then this Microsoft Excel data is saved in a command delimited way. Please come here. Then I will select this one. Say OK. So let's select this one, stage elevation format. Since I'm saving the format in this way, for river select river name, for ridge select ridge name, for river station select cross sections, for station elevation. Okay. Then I can select this one, assign a unit, then you can check it from this one, assign unit, next this one, from river ridge streamlines, for the streamlines, I click this one. then next. Already your river name is Bako River, and your ridge name is Bako Tepi. You have different cross sections: 1000, 900, 800, and 700. So this river, Bako River, is found in Tepi, around Tepi, which is one tributary of Baro Akobo basins. This Baro Akobo basin is one of basins found in Ethiopia, so I can name the river name using Bako. Then I can finish the import data. Then click this one, finished. Already your cross section is entered. Your river name is Bako. Your ridge name is Bako Tepi. When I click this one, already your stations and elevations are entered. This one is the format. This data is gained from the format I saved on Microsoft Excel. So you can view for the others. This one is 900 river station. For 800 cross sections, river stations, you have such line. For 700, you have such line. So the other point, here is leftover bank channels and the right over bank. If your channel is between this, the length between this to this is your left over bank, and the length between these to this is your right over bank. So you can fix your left over bank and the right over bank at each cross sections. So you can enter this one. So go to tables and then insert this mining coefficient. This mining coefficient for different channels is recommended in different manuals. So it is unlined channels. For unlined channel, you have to select your mining. For right over bank, for left over bank, you can select, then you can fix your mining value. This value is fixed depending on investigations. So in our tutorial, we can use this one by selecting all these and set the value for L1 and the leftover bank is about 0.042. Okay, for your channel, set value which is about, for your leftover bank, you can fix the value for your mining to 0.032. your right over bank, you can set your money coefficient. I mean money coefficient 0.42. Okay. Okay. Ready? The money coefficient any value is entered for each cross sections. Then I can insert again my rich ladies. That means your leftover bank, your channel, and then your right over bank. Like I said, the value for leftover bank is 10. Okay. For your channel, set value 1.5. For right over bank, set value 10. Okay. Then you can view leftover bank reach length, your channel length, and then your leftover bank reach length. But since I need to fix my channel as between this point, 2 points, then these stations minus these stations will give your leftover bank is about 11.5. Between these stations minus this station will give you your channel, which is about 80.5. And then your right over bank is this station is minus this one, which is about 3.4. Then apply data. Then I can insert for leftover bank for reverse station 900, which is 11.5 again. This one is what? 6. This one is 6.4. Like that. Also, I can fix this left bank and the right bank. This left bank for this is about 72.5. 72.5 for right bank. I have about 91.1. For TV station 900. I can fix value for left bank, which is 72.5. Again, right over bank 91.1, like that. TV stations 800 for this 50.8. This one 2.3. For left for your left bank, which is 76.8. 26.8 right bank, which is 91.1 right arrow. This one update leftover bank. Already your left and the right bank is fixed. Can save my geometric data. Already your geometric data is inserted, then I can insert this 3D flow data. By selecting this import, I can select this one, I can say description flow analysis 1. Then I can add this profile, which is 4, so make it 4. Then at profile 1, we have 10 meter cube per second discharge. Profile 2, we have 20. Lastly, we have 30, and then profile 4, we have 34 meter cube per second. 34 meter cube per second. So I select this one, which boundary. Since I have not having grading curve, select this one, and for upstream, select normal. Upstream slope for normal depths, enter value, then enter upstream slope for normal depths computation for reach Pacotepi. There is this one slope which is 0.12. Okay, for downstream select the normal depths because you don't have a rating curve, so assume as it is normal depths, then enter value which is 0.012. Okay, now for known water surface, this one is flow, this one is elevations. So for this 34 meter cube per second, you have elevation 49.8. For 30, you have 49.5. For 20, you have 48.8. For 10, 48.7 meter. So after you enter all this value, you can say okay. So you can view your rating curve, but entering rating curve will override the boundary type for all profiles on these sections. So okay, cancel this one. There, select this, enter this one. Say okay. Look at apply data. Already your data is applied here. Save your data as this Hec-Ras one. Create here. Let's say std flow. Or say ready. So project is saved in this Hec-Ras one. Then you enter geometric data. That's it one is steady flow analyzed folder. You can save this one and run your steady flow analysis. Since you don't have rating curve, you don't know as the flow is subcritical and the supercritical, but you can do this one. Is mix it one, select the mix it, then compute. Your steady flow simulation is started. Okay, already your steady flow computation is finished. So already this one is your result. There you do this. Again, you can insert your bridge data. So select this one to enter geometric data for your bridge. Then you have symbol. Select this one. Select options. They can add set bridge. So you have 1000 river stations, 900 river stations, 800 river stations, 700 river stations. Let's say you are required to construct bridge between river station 900 and 800 at 850 river stations, 850 meter. Okay, your cross section is like this one. So you can enter your bridge geometric data by selecting which one. That means you may have cross section bounding. There is 900 and 800 because you are your bridge river station is at about at 850. Can enter this road data. Select this one. There you can fix your distance for data for this your road data distance should be this distance plus this width should be less than distance, which one is 80.6 meters. Then I fix this one. Let's say this is 5 and this one is 10. Right, wheel coefficient is 2.6 in this case. Then at stations 0, at station 0, at let's say at station 0 you have 50.5 high court, 50.5 at 72, at 72.2 you have 72.5, this 72.5 you have high court 50.5. Okay, that's 72.5. You may have high court, low court, let's say 50, let's say 50. 91.1, 0.5 high court, 50, 91.1, let's say this one. Let's say low court is as this one and the high court is as this one. Five and 7.5. Let's select this wheel type, which is broad crested, and then set maximum submittancy 9.5, 0.95. Again, select for downstream river stations your high court and the low court, 0 stations, since it is you are fixing for the same have maximum or high court 25, 25, 24, low court 50, 25, low court 50. This one you have 25, only high court. Okay. So you can view your bridge at upstream. This one is your low court. This one is your low court. This one is your high court. So at this 72.5 you have high court. Also you have low court. So you can fix the value on this point at 91.1, 1.1 around this you have low court and then high court. Save geometry data and select bridge and enter the second data, which is field data. So bridge becomes structurally sound when it has pier and the sloping abutment. So the piers for this, the elevation 48.5 for this one 48.5. So there say okay. Already your pier data is entered. So you can enter center line station at upstreams. Maybe at 80 you are required to design, or to be at these stations. At 80 stations you can fix your center line 80, but it is not recommended to construct pier in the river at middle because it is most appropriate to locate pier at this site, except if it is absolutely necessary to design it. You can design it, but let's say your center line at upstream is 80. For this one 80, okay, you may have your pier in this way. So you can add the other pier. Again the same wheel width and the same elevations is the first, but different center line. Fix your peer at this point. Then let's say your center line is 86 on the second 6. You have your table switch and the height. You can set the value here. Say OK. Tell you at your peer data target data is your sloping attachment. So you may enter this one, but for this model you insert your bridge data, the other one is your peer data. Then select this bridge and I can insert sloping attachment data here for upstream. For station 70 to 49.2. Your sloping attachments is fixed. Then you can run your steady flow analysis or makes it like complete. Already your simulation is complete. Then you can view your result. For example, three-dimensional view. I can view three dimensionals. is all about what your page should like. So for your profile 1, uh, for profile 2 you have such like, for profile 3 you have such like, profile 4 for 34 metric cube per second discharge you have such like water surface profile. This is all about page design. You can see the water surface profile for profile 1 metric cube per second, for discharge 20 metric cube per second, for 30 cube per second, and 40 34 metric cube per second. View the general profile plot where this one is velocity in left profiles, this one is velocity in profile 4. At each station you have different velocities. This one is velocity in profile 4 in the channel. So in your channel you may have velocity about around here is 1.55. This point we may have 1.56. Then at stations is at distance, main channel distance about 63.81, you may have 1.12. Detailed output tables. From this table you get energy grade line at upstream, water surface, total discharge for profile 1, for layer 1 critical water surface, maximum channel depth, velocity total area, flow area in meter square, fraud numbers. So depending on these fraud numbers you can specify critical flow, subcritical flow, or supercritical flow. You can check this one. Let's say for profile 4 you have total discharge 34, you have fraud number which is 0.82. Can do this one. There is warning disease. The energy equation could not be balanced within a specific number of iterations. The program used critical depths for water surface and the continued on with calculation. So you have to check this one. For profile 1 you may have different warning. Velocity head has changed by more than 0.15 meters. This may indicate the need of additional cross-section. You have to add additional cross-section. Almost you have 4 cross-sections. Cross-section 1000, 900, 800, and 700. You can add the other cross-section in order to limit this warning. The other one is convenience ratio. This indicates the need of additional cross-section. While you need additional cross-section, you can omit all this. Thank you for watching this tutorial. In this tutorial, I hope you understand that how insert geometric data in the steady flow analysis, and how insert bridge data and analyze steady flow. Then view the results in different formats. This is all about Hec-Ras.